Hello everyone. In the last video, what I did was I solved this basic circuit here, and we used KVL and KCL to write out equations so we can solve for V0. What I want to do briefly in this video is I want to create the same KVL equation, and the only thing is I want to change the orientation of these voltages. And I want to do that just because I think that when dealing with these issues of what sign the voltage should be, I think students tend to get confused. So I want to kind of illustrate how this works, how even even if we flip the orientation of VR1, that the math still works out. So I'm just going to go ahead and show you how that works. So let's go ahead and create a new page here, and let's go ahead and sketch our circuit out. We have Vs, we have our two resistors, and then our two resistors in parallel. And then we have V0 here. This is R1, R2, R3, R4. And we want to do a KVL loop around here. And so remember, KVL states that the sum of the voltages in a loop, or the voltage drops in a loop, is equal to 0. So the question then comes, well, how do I know the polarity of each voltage that I encounter? And the cool thing, though, is that I can go ahead and assign whatever polarity I want to the voltages in the resistor. And as long as I'm consistent in my equation, all the math will work out to where you will arrive at the same answer for V0 in the end. So last time what we did is we defined it this way. We put plus here and minus there. We said VR1. I'm going to flip it this time, and we'll just do minus plus VR1, and then minus plus VR2. And as long as we're consistent, all the math will work out to where we still arrive at the same equation that, that we're wanting to solve for V0. That's part of the beauty of how all this works, is that you can just go ahead and assign a direction and or a certain polarity, and if you solve for something and it ends up being negative, then you know that it actually has the opposite polarity. But in the end, all the math works out. So you can just assign a polarity, and then we can go ahead and we'll go ahead and do our voltage loop here. So again, going around here, first sign that you hit is the sign of the voltage in your summation term. So we hit a minus sign here. So that's going to be minus Vs. Then we have plus, or I'm sorry, then we come around and we hit a minus sign here. So that's going to be minus VR1. Then we continue around in the loop, and then we hit a minus sign here. So that's going to be minus VR2. And then we go around here, and then we hit a plus sign here with our V0 here. So that will be plus V0 is equal to 0. Then what we have to do is we need to substitute using Ohm's law, VR1 and VR2. So if we call this current like we did in the last video, we'll call this I1. If that's I1, then we can ask the question, what is VR1? So VR1 is actually going to be negative I1 times R1, and VR2 is going to be equal to negative I1 R2. And the reason for that is because of the way we've defined these orientations. Remember what Ohm's law says. Ohm's law says that if you have a resistor and you apply a voltage across it, actually let me move this resistor. Okay, if you apply a voltage across it, plus and minus voltage, then it will cause a current to flow, current I, to flow from the positive side to the negative side. And that I will be equal to V over R. And this makes sense, right? If you remember that plus indicates the point of higher potential energy for the charge, minus indicates a point of lower potential energy. So if you apply this to a resistor, then current is going to naturally flow from high potential to low potential, just like water flows from a high height to a low height. And it will flow from the positive, from the region of high potential to low potential. So that's how it works. But notice in the way that we've defined this, the current I1 is going from the minus to the positive. But we just said here, Ohm's law says that when you apply a voltage that's plus and minus here, then the current will go this direction, from plus to minus. So that's why when we calculate what VR1 is based on I1, we have to put a minus sign there, because of the way this current I1 was defined. If it was defined the other way, then it would be I1, just I1 times R1. It would be positive. So remembering that notation is really important. So then what you can do is you have these values now. You can just plug these into your equation there, and then we could also write another like KCL equation, the same equation that we did in the previous video. And if you work through the math, that's just something you can do on your own time. But if you work through it, you should find that you will get the same answer. So hopefully that kind of helps and clears things up a little bit when it comes to sines. We'll continue to do more examples. I'll continue to try to find different ways of explaining it so that if you're still kind of confused, hopefully as we continue to work these examples, you'll begin to understand. So thanks for watching, and I'll see you in the next video. Hello everybody, thanks for watching. If you found this content helpful, would you please consider liking and subscribing to the channel? That will help other people find it. And if you won't do it for me, will you do it for my cat, Muon? Named after my favorite subatomic particle, by the way. So, she will be very, very upset if you do not like and subscribe. So please, don't disappoint. How could you say no to this cuteness?